Right, here we have here's the converse of the triangle proportionality theorem. Now, anytime you have a converse, it just means you've changed the direction of your theorem. So previously our theorem said if you have the parallel lines, okay, so if you had the parallel line to the third side, and that's spelled incorrectly, let me fix that. If it was parallel, then you had proportional parts. Okay, when you do the converse of something, you're switching the direction. So now instead, those will be switched and we'll be saying, if you have the proportional parts, then you know that you have parallel lines. Okay, so that is a good thing to know about converses because that's exactly what they do to any theorem, is they switch the order. It is true that if you know that you have proportional parts, so in this figure, we knew that AE over EB, the top or the bottom side of that triangle, equals AF, the top, over FC, the bottom. That is a proportion. If those sides are proportional, then that line that was dividing them is parallel to the third side. Okay, so again, we're just going backwards from what we knew before. This question asks, what can we determine about LP and MN? My first thing I would want to do is find those. Where are they on the figure? And kind of highlight them so I know. Well, there's LP. And here's MN. You might look at them and say, well, they look like they might be parallel. And you might say, well, that's what we've been doing, so that could be the case. But we have to check and make sure the sides are proportional. And if the sides are proportional, then we can determine that those two lines are parallel. Okay, so let's set up each of our proportions. So the top part here was 24 over the bottom section 36. And let's set up the other side. The top portion was a 16 and the bottom portion was a 24. Let's reduce those to see if they are in fact equivalent, which would make this proportional, and we would know those sides are parallel, or those lines are parallel. Let's reduce these. Let's see, 24. 12 will go into 24 and 36, goes into 24 twice, and it goes into 36 3 times. We're just reducing that fraction. So this one has a fraction of 2/3. Let's do the other one. What goes into 16 and 24? Lots of things, but let's get the highest one possible, so we have to do less work here. And I'm thinking 8 will go into both of those. 16 divided by 8 is 2. 24 divided by 8 is 3. So notice when I set up my two sides, they have exactly the same proportion. So what can we determine about this? We can determine that LP is parallel to MN.